So in previous class, if you remember, we were discussing uh, firstly, I told you about the multipole expansion, and then in previous class, we entered into a new section that was electric field in matter. And I told you that this is about how electric field affects the matter or how much change it brings to the matter and how matter responds to the electric field. So a combination of all this we have to study. And I also told you that one very important factor, which is the measure of how much change electric field has brought to the matter, is polarization, right? So if alpha is more, that
Yes,
means the matter was more responsive to the external electric field, and if alpha is less, so that means that matter is less responsive to the electric field. So what you will suggest, in hydrogen more change will happen or in cesium atom?
Cesium.
In cesium atom, right?
Yes, sir.
So now I am going towards some problems, and the first one is uh, electric field produced by a uniformly polarized sphere of radius capital R. Okay. Just a second. Before that, also, I want to do one question. Just a wait. Please write, according to quantum mechanics, the electron cloud of hydrogen atom is given by the charge density this. Find atomic polarizability of such atom. I mean, it is in ground state. So, आपको याद है कि I have taken a very primitive model, a very simple model.
Yes.
And I
Yes, sir.
showed you that alpha for that was 3 epsilon naught V.
Yes, sir.
Please check from the previous class.
Yes, sir. It is done.
Alpha was 3 epsilon naught V from a primitive model. What was primitive in that? रो वॉज यूनिफॉर्म, याद है? चार्ज डेंसिटी को मैंने कैसा ले लिया था? यूनिफॉर्म ले लिया था, जबकि चार्ज डेंसिटी अगर आप क्वांटम मैकेनिक्स से देखो तो कुछ ऐसी होती है, राइट? सो नाउ कैन यू सजेस्ट, so obviously alpha will not be this, it will be something different here, yes or no? So can we calculate the value? The method is simple, that this is the radius, say a, it is given here now, Bohr radius, and we have to get the value of electric field somewhere here, right? Yes or no?
Yes.
And this field will balance with the external field applied. Suppose I have applied E, so it will balance with this. E is equal to EE, correct? Let this is EE here. On this charge Q, suppose that is the field applied. So it will balance this. So let us calculate electric field here. Let me call this point as point P. Electric field at point P. तो गॉस लॉ लगा दें.
Yes, sir.
Integral E dot dA is equal to
Rho d tau by epsilon.
rho d tau from 0 to R. Yes. You
Yes.
want to calculate the charge content here. So this will be E into 4 pi R square बोलो
Equal to 1 by epsilon 0.
is equal to
1 by epsilon
1 by epsilon naught,
q by pi a cube.
and what is rho?
Q by
Q by
Q by pi a cube
pi a cube
e raised to minus 2r
and integral 4 pi बाहर कर लूं.
Yes, sir.
4 pi 0 to R
R square
R square e to the power minus 2R by a and dr. सबको समझ आ रहा है ना कैसे डी टाउ को यूज कर लिया? You know ना, d tau is 4 pi r square dr. Okay, when theta is symmetric, phi is symmetric, no problem. Yes.
Yes, sir.
करेक्ट. अब जरा ये कैलकुलेट करो. So E into 4 pi r square is equal to pi and pi will cancel. 4q by epsilon naught aq. What about this? First function integration of second minus derivative integral plus derivative integral. Zero to r. Limit put करना जरा. Put the limit properly.
सर नीचे पर कट है थोड़ा,
Hmm?
कैमरा थोड़ा पीछे, ये सब.
इंटीग्रल u v से कर रहा हूं. Okay. So lower limit will be 0 in first two terms, but in last term it will survive, right?
Yes, sir.
So कायदे से रखो जरा. So this electric field EE will be 1 upon 4 pi epsilon naught Q by R square in bracket 1 minus E minus 2R by A into 1 plus 2R by A plus 2R square by A square bracket close. Okay, please check this.
सर ये पाई सर कैसे आया?
कौन सा पाई?
ओ सॉरी सर, ठीक है.
देखो आ रहा है सबका?
यस सर.
So you can see that at equilibrium what will happen? The field that is created here will be balanced by field E. Yes, जैसे पिछली बार किया था.
यस सर. यस सर.
So E will become equal at some, say some R is equal to D. It will balance and it will become 1 upon 4 pi epsilon naught Q over what?
डी.
Q over
सर आर इक्वल टू डी ना?
R is equal to D. what will be the value? ये वाला पार्ट तो हो गया, ये मिटा दूं?
हाँ सर। सर
हम्म
सर जब एक्सटर्नल फील्ड कोई मैटर के ऊपर होगा,
हम्म
तब सर इनसाइड जो फील्ड है वो तो बहुत ही कम है। अ, या सेम है?
कम है का क्या मतलब? जैसे जैसे
मतलब
जब तुम्हें एटम के केस में समझाया था मैंने कि शुरू में पॉजिटिव और निगेटिव एक ही जगह है, बट जब तुम फील्ड अप्लाई करते हो तो दे गेट सेपरेटेड, राइट?
ओके।
इस सेपरेशन की वजह से ये जो इलेक्ट्रॉन क्लाउड बन रहा है, पॉजिटिव तो यहां आ गया,
हाँ
वो फील्ड इधर क्रिएट कर रहा है, तो वो इस पॉजिटिव चार्ज को इधर ले जाना चाह रहा है, राइट, इक्विलिब्रियम में। बट जो एक्सटर्नल फील्ड है वो इसको इधर ले जाना चाह रही है, तो दोनों कहीं पे बैलेंस हो जाएंगे। So
यस।
that balance point will be where E is equal to EE. The same thing is happening here also.
ओके।
You have बस यहाँ पे सिंपल डिस्ट्रीब्यूशन था, यहाँ पे कुछ क्वांटम मैकेनिक्स से रो ले लिया है तुमने। You have taken रो from quantum mechanics, okay?
यस।
तो एक बार जरा R इज इक्वल टू डी पे इसको ओपन करके लिखना और स्क्वायर वाले टर्म्स को नेग्लेक्ट करना, करके देखना जरा। Q बाई डी क्यू, Q बाई डी स्क्वायर here and
वो सर एक्सपोनेंशियल को ओपन कर दे क्या?
हाँ,
Okay.
this will come out to be 4 by 3 pi, करके देखो जरा, d क्यूब बाई a क्यूब।
पाई कैसे है सर?
4 by 3 d cube by a cube. Please check this. It will become like this 1 minus, ये क्या बन जाएगा? 1 minus 2r by a,
डी बाई
hmm?
2d बाई
2d by a, and here
1
1
प्लस।
plus 2d by a, correct?
Yes.
So it will become 1 minus 1 plus 2d by a minus 2d by a. And one more term we will have to take, na? Otherwise nothing will come out.
यस सर, और एक स्क्वायर टर्म लेना पड़ेगा।
एक स्क्वायर टर्म और लेना पड़ेगा, एक जगह ले लो स्क्वायर टर्म और, just take one more square term, it will become 1 minus, पहले 1 minus छोड़ देता हूँ, 1 minus, it will become 1 minus 2r by a, फिर क्या हो जाएगा? प्लस
प्लस 4r स्क्वायर बाई 8 ए स्क्वायर
4r स्क्वायर by a स्क्वायर, यहाँ तक,
बाई एक 2 होगा।
और by 2 फैक्टोरियल, राइट?
Yes.
और यहाँ 1 plus 2r by a plus 2r square by a square, okay? So it will become 1 minus 1 plus 2r by a plus 2r square by a square. फिर here minus 2r by a minus 4 r square by a square and minus 4 r cube by a cube. Correct?
Yes, sir.
Plus 4 r square by 2a square plus 8 r cube by 2a cube and plus वो छोड़ दे रहा हूँ power 4. Okay, this much. What will be cancelled? जल्दी बताओ.
2r by
2r by a and 4r square upon a square.
This is also cancelled, right?
Yes, sir. Plus 2r square by and minus 4 square by
4 r square by
that is 4r square by 2 square. Sir. So,
हाँ, this is 2 r square by a square and this is also 2, right?
yes, sir.
So this will be cancelled. देख रहे हो, पहले दो टर्म तक कुछ मिल ही नहीं रहा है.
Yes, sir.
नॉर्मली होता है ना कि हमें शुरू में ही अप्रोक्सीमेशन मिल जाता है, बट दोस टर्म्स आर बिकमिंग 0 and then this one is cancelled by this. What we get finally?
4d cube by a cube.
सर एक क्यूब का कोई माइनस का क्यूब भी कट रहा है ना?
Cube
क्यूब नहीं कट रहा है.
नहीं वो
हाँ,
माइनस
-4 आएगा.
-8 by 2 cube.
4r cube by a cube.
अरे पता है हम लोगों ने क्यूब तक लिया है ना, तो पहला टर्म यहाँ से भी एक और आएगा. Are you getting it?
Yes, sir.
Because we have taken up to cube, so cube will be because of this one also, right? What will be that?
1 by 3 factorial
1 by 3 मतलब 1 by 6
हाँ.
and what?
माइनस होगा
8r cube by a cube.
Minus
8r cube by
8 r cube by a cube. तो कितना हो जाएगा? It will be 2 3 ja 2 4 ja, so it will be 4 by 3 r
D cube
cube by a cube. Okay.
Yes. Yes.
See, you have to be really patient, right?
Yes, sir.
So that's why this. Now understood this? Now you can directly write now. E is equal to what? Quickly write. This d square and this will cancel
And P equal to QD
and p is equal to qd. So it will become p
by 3 epsilon 0
by 3 epsilon naught
pi a cube.
and 4 pi
3
Sir,
pi
4
epsilon naught a cube.
4 will
4
cancel.
cancel, sir.
So p by pi epsilon naught, right?
Yes, sir.
P has sir. 3 pi epsilon naught.
P by 3 pi epsilon naught and a cube will be E. So what will be alpha?
1 by 3 pi epsilon 0 a cube.
3
pi epsilon naught.
pi epsilon naught a cube. पहले क्या आया था?
3 epsilon naught a cube.
What we got before from primitive model?
3 epsilon 0 b.
पहले 3 epsilon naught a cube आएगा.
Oh no, 3 epsilon में b आया था.
No, in pi also I told na.
Yes, yes, sir. That we have to convert. B is 4/3 pi a cube.
It was 3 epsilon naught. Initially it was alpha is equal to 4 pi epsilon naught
a cube.
pi epsilon naught a cube. This was the primitive model. And from the quantum mechanics,
Hello sir, your voice is not coming.
hello,
Yes, sir. But yes,
आवाज नहीं आ रही मेरी?
नहीं आ रहा है सर.
बीच में ब्रेक हो रहा था
आवाज
क्या?
सुनाई दे रहा है क्या सबको?
No, no. It is clear, sir.
ओके ओके, ठीक है. हाँ पुनीत, ओके, थैंक यू. सो ये समझ आई बात? Before it
Yes,
was,
sir.
so because this is material property, you should understand it 100%. Whatever you learned was the calculations which you are using now, na Gauss theorem. But how your material is responding, that you should understand. So before, please check your copy. It was 4 pi epsilon naught a cube
Yes, sir.
from the primitive model.
Yes, sir.
And with quantum mechanics and ground state and using the approximation, because we are not considering r to the power 4 term, so we are getting 3 pi epsilon naught a cube. Okay, so this is kind of classical and this is kind of quantum. समझ आई बात?
Yes, sir.
Yes, sir.
Okay, कंचन आपको आ रही है आवाज? आपको हाँ, आप किसी को कोई डाउट हो तो पूछ लो. वेरी नाइस क्वेश्चन.
नहीं सर, डाउट नहीं है, लेकिन क्लासिकल में तो बेहतर आंसर आ रहा था इससे. हल मतलब हाइड्रोजन प्रॉब्लम इक्वल टू 0.16 समथिंग आई थिंक, एंड द
एक्चुअली
अदर वाज.
क्वांटम में तुमने अप्रोक्सीमेशन कर दिया है ना, समझ रहे हो?
यस सर, यस सर.
मतलब बहुत स्कोप है पावर्स को ज्यादा लेके और अच्छा बनाने का. अब तुमने सिर्फ एक टर्म लेके और अप्रोक्सीमेट कर दिया है. दैट्स
यस
व्हाई.
सर.
ओके,
यस सर, यस सर.
सो एटलीस्ट मॉडल तो आ गया ना पिक्चर में. इफ यू टेक मोर एंड मोर टर्म्स, यू कैन मेक योर दिस थिंग, और ऐड होता जाएगा. नेक्स्ट टर्म वाला भी ऐड होता जाएगा यहाँ पे. ओके, सो इट विल मेक इट बेटर एंड बेटर.
यस सर.
ये बात है. ओके, is this okay?
Yes, sir.
Okay, now if I say that P is proportional to e to the power 1, proportional to e square, proportional to e half, which one of them is correct?
E.
First one.
First one.
Yes, sir.
Actually, I told you जब मैंने P is equal to alpha ही बताया था कि this is not a fundamental law, okay? Because this is only good for some simple cases. E may achieve different powers in different situations, okay? For example, when your laser is of high power, it will become alpha E plus beta E square. You have to consider more terms. समझ रहे हो बात को? Yes?
Yes.
Yes, sir.
So it is only when the value of E is less, the E square becomes more less and E cube. Because ultimately it is Taylor series, na? समझो बात को.
Yes, sir.
It is infinite series. Mathematically सोचो. So those terms can be only neglected when the squares and cubes are less and less. Otherwise, you have to consider them. So that's why always remember P is equal to alpha is not a fundamental law. ठीक है? कुछ cases में it may become rule of thumb कि आप P और alpha E को compare करके alpha की value निकाल लो, but it is not a fundamental law. Correct?
Yes, sir.
Let me show you how. Suppose I consider a problem in which, suppose this is radius r, and in this the rho is continuously increasing as we move from center towards this. For example, I take rho r is equal to some br, where b is some positive constant. Okay? ठीक है? तो जैसे जैसे बाहर की तरफ आओगे, the charge density will become more and more. Let us calculate polarizability of such a substance. Ab now you have idea na how to get it? Bolo bhai.
Yes, sir.
E into 4 pi r square is equal to, yes, 1 over epsilon naught integral
BR
br
into 4 pi r square
4 pi r square dr 0 to r. Correct?
Yes, sir.
So it will become E into 4 pi r square is equal to 1 by epsilon naught b into 4 pi. यहाँ पे कितना हो जाएगा? R to the power 4 by 4. Okay. Check this.
Yes, sir.
And 4 pi will cancel. R square and this will cancel. So E will become B by epsilon naught into
R square by 4.
4 into, let me call it D square. Okay. Suppose the charge has shifted to here and this is distance D. This is the point where final equilibrium has reached. And equilibrium I have already explained you in the presence of external electric field, right?
Yes, sir.
Yes.
So this is the situation. So E becomes B by F4 epsilon naught D square. Is this okay?
Yes.
Now, if I consider the dipole moment P is equal to QD, what will happen? E will become B by 4 epsilon naught. Check करो जरा. P square by Q square.
Yes, sir.
Right?
P is proportional to root E.
And P became proportional to e to the power half. Can you see in this situation, अगर option में तुम्हें दे दूं कि ऐसी charge density है and I give you 4 options that P is proportional to e to the power half, e to the power 1, and आपने अगर ये किया नहीं है तो आपको लगेगा यार P तो हमेशा ही e to the power 1 के proportional होना चाहिए ना?
Yes, sir.
But that will be
Wrong.
wrong. That will be a mistake. देखो जरा ये समझ आई सबको बात? And Q charge is that charge which is shifted here, right? इनिशियली सबका सेंटर मान लो यहाँ था, शिफ्ट होने की वजह से ये क्यू चार्ज है। ओके,
Yes, sir.
लाइक हर केस में हम कर रहे थे। एनीथिंग यू वांट टू आस्क? पिनाकी,
No, sir. Fine.
कॉन्सेप्चुअली समझ आ रही है बातें?
Yes, sir.
ओके, now next question is that suppose there is a neutral atom like this, and there is a point charge q like this. This neutral atom has polarizability is equal to alpha. Okay, this neutral atom has polarizability how much? Alpha. So because this has got electric field, this charge will be attracted or repulse, जो भी होगा, attraction or repulsion होगा, because of this q charge there will be a field, and because it has polarizability there will be a moment, dipole moment, and because
sir.
of that dipole moment there will be electric field. So all those things are related, right?
Yes, sir.
तो ये बहुत अच्छी प्रॉब्लम है। ये सपोज कोई एटम है, एंड इनिशियली आई यूज्ड टू से दैट एटम के बाहर एक इलेक्ट्रिक फील्ड है, उसकी वजह से सब कैलकुलेट करके वी यूज टू गेट द अल्फा, राइट? Now it has been given because alpha is a material property, it is property of the atom. Now this atom is kept near q. What will happen? This q, suppose it is placed at a distance r, it will create electric field, yes or no?
Yes, sir.
What will be that electric field? E is equal to 1 upon 4 pi epsilon naught
Q by R.
q by r square, correct?
Yes, sir.
And p is alpha e, so p will be alpha into 1 upon 4 pi epsilon naught r square, correct?
Yes, sir.
And p will be in the direction r cap, because you know this will be the direction r cap, so this will be the direction of polarization, correct? Because this is positive charge, positive will be shifted this side and negative will be shifted this side, correct? Now this has achieved polarizability. ध्यान से देखना, बहुत अच्छा क्वेश्चन है। This has got the polarizability. Now this will create electric field here, yes or no? Because this is
Yes,
a
sir.
dipole, and it is this dipole will create electric field here. So, and this has got dipole moment p. So electric field due to a dipole, So now see this problem as if some dipole is kept like this and we want to calculate electric field at a point, correct?
Yes,
ये
sir.
problem है अब. This is the dipole. This is the center of the dipole. You want to calculate the electric field at this point on the axis of the dipole here. So what is r cap? from the dipole to this side. This is r cap.
Yes.
Yes or no?
Yes, sir.
And this is P. This is direction of P. So what is electric field? किसी को याद है? P by 4 pi epsilon naught r cube
R cube 2 cos
Two.
theta r cap.
2 cos theta r cap plus
Sin
sin
theta.
theta theta cap. Okay.
Yes, sir.
So what will be the electric field here? What is theta? Pi hai.
Pi है sir.
So this term will be gone. So field will be, bolo, minus 2p
Okay.
by 4 pi epsilon naught r cube r cap. ये किधर भागेगा चार्ज? हेलो?
उसकी
डाइपोल की तरफ.
और ये तो ऑब्वियस है, यहाँ देखो नेगेटिव चार्ज अपीयर हुआ है, अट्रैक्ट कर लेगा इसको.
Yes, sir.
ये कोई बहुत बड़ी बात नहीं है, समझ लेना. ये पॉजिटिव चार्ज दूर है. This negative charge is closer, so it will attract it, right?
Yes, sir.
So this is
Sir,
the
ये-
field. Yes.
सर ये ऑसिलेट नहीं करेगा?
Oscillate?
म्यूचुअल
ऑसिलेट क्यों करेगा? जैसे ही तुम इसको डिस्प्लेस करोगे ये इधर भाग जाएगा.
हाँ.
There is nothing to stop it, ना? It will just run into it. Okay?
बट वो भी तो और पोलराइज करने का कोशिश करेगा.
वो और नेगेटिव हो जाएगा तो और ज्यादा भागेगा उसकी तरफ. It will come closer and closer. It will become more polarized. So this tail will become more negative. So it will be more attracted and will be crushed into it. Right?
Okay.
समझ आ रहा है भाई सबको?
Yes, sir.
Yes.
So what will be the force that will be acting on it? Force on Q
PQ.
will be minus 2 PQ by 4 pi epsilon naught R cube R cap. अब ये R cap किधर है? ये R cap नहीं है, समझ रहे हो? जब मुझे फील्ड निकालना हुआ तो ये R cap है. इस बात को अच्छे से समझ लेना. Understand this thing properly. Hello.
Yes, sir.
Yes, sir.
Right now, when you want to apply this dipole field here, then R cap is away from the dipole, right? So this is the force. कितना अच्छा question है ना? Everything is cleared. How you bring a field, this is polarized, then it also starts behaving like a source of electric field. Yes or no?
Yes, sir.
And just check what type of force it will be. Please see this. This force will be attractive and it will be 1 by r to the power 5. ये कितना अच्छा क्वेश्चन है, देखो. Rarely मिलता है आपको ना ऐसा force. Because of this P here, you see what is the proportionality of P? R square.
Yes, sir.
So when you will bring it here, it will become r to the power 5. And what will be the nature? Attractive. Such a beautiful question to understand the polarizability and this and that. Please ask if there is any doubt. सब कुछ just simple calculation से निकाल लिया हमने with together, right? That is the beauty of knowing things. किसी को कुछ पूछना है? Okay, then we will continue in next class. Okay.
Okay, sir.
Thank you so much. Please revise
you,
these
sir.
concepts. 100% clarity होनी चाहिए. देखो एक ही में R cap is because I was seeing this, then R cap was this, then I wanted electric field from this, and then R cap became this, right?
Yes, sir.
Okay, then thank you.
Thank you, sir.
Thank you,
Thank
sir.
you. Thank you. Good night.
Right, sir.